Hello everyone, I'm Sanjayrahul from second CSCB, roll number 581. Today we are going to listen about the topic understanding random variables, binomial distribution and Poisson distribution by analyzing the mean and variance. So let's go through the topic. So introduction to random variables. So what are random variables? The random variable, the name itself is saying that the random variable. So a variable whose values are depend on outcomes of a random experiment. So the random variable outputs are given by random phenomena. So there are two types of random variables. So one is discrete and another one is continuous. So the discrete variables take on a countable number. So which which are able to outcome on a countable number of distinct values. So these are countable. Examples are anything we can count, like number of flips of a coin, or the outcomes of a flipping of a coin, or the outcome of taking a ball from a box. And another one is continuous, which are uncountable. That means they won't be infinite, but we cannot count. So like see, we take an average of an individual, the exact height of individuals in a population. So we cannot count each and every person, but we can take a value about one thing. So like that we use the continuous. So mean, expected value of a random variable. The name mean, we all know the meaning of a mean. If for people who don't know, mean is just an average of an outcomes. Mean is just average of outcomes. Okay, mean is just average of the outcomes. So we have the formula here. We have the formula for mean. The mean of a random variable is the long run average values of a repetitions of an experiment it represents. So average value of a long run. So for discrete, it is nu equal to e of x equal to sigma x into p of x by mu, and continuous equal to nu equal to e of x equal to integration of x into f of x dx by mu. So we can calculate mean like that. So let's go to the variance. Here the variance is depending upon the mean itself. So the variance depending upon the mean. So the variance depends upon the mean. The variance of a random variable measures the spread of its values around the mean. We have the formula. We represent the mean with nu, as you can see here. In both discrete and continuous, we use nu, and the variance is represented with nu square, sigma square. So we have discrete and continuous formulas. You can see sigma square equal to variance of x equal to sigma of x minus u whole square into p of x by sigma square. So here also sigma square equal to x minus nu whole square into f of x dx sigma square. So the variance is outcome of rolling a fair six-sided die. So it depends on like that. Next, binomial distribution. What is a binomial distribution? A binomial distribution models the number of successes in a fixed number. As you can see here, a binomial distribution models the number of successes in a fixed number of independent trials with same probability of success. So let's take an example. There are six people opted. They rolled a dice, and each and every people picked, and each and everyone picked a numbers, distinct numbers. So there is equal opportunity for everyone to get success. So here, the binomial distribution models the number of successes in a fixed number of independent trials So as many trials you can see, we can count, there are fixed, there has to be fixed number, they cannot be infinite with the same probability of success. As I said in the example, each and every person has the same probability, and the parameters here are number of trials, how many trials we are going to do, probability of success, what is the probability of success for each person, each experiment, each person, each probability, each variable. So the mean and variance are as follows: mu equal to np by mu equal to np, wherein sigma square equal to np into. So if you are able to calculate the mean, you are able to calculate the variance. If you are able to calculate the variance, you are able to calculate the mean. So both are interconnected. Specifically, mean is very important. Mean, if you calculate the mean, you can calculate the variance very easily. So you can see np into, here the mean nu will be np. So sigma square equal to np into 1 minus p by sigma square. Np into 1 minus p into sigma square equal to np into 1 minus p again. So it repeats. So the sigma square will be 1 actually. So the example would be number of heads in 10 coin flips with the probability 0.5 into 0.5. So number of heads, how many number of heads can happen in 10 coin flips? Maximum 10, minimum 0. How many that can happen? We can count with the binomial distribution. And then Poisson distribution. It is also like this binomial distribution, but the Poisson distribution models are the number of events occurring with a fixed interval of time or space where events occur independently. So if like there has to be some fixed rate or fixed, I mean there has to be fixed space or fixed time interval or space interval. So in that interval, the number of events of success, the number of events occur in a constant rate. So there has to be constant and there has to be interval. Then we can use the Poisson distribution. There are casts for this too: lambda, PMF, mean and variance, etc. And mean mu equal to lambda by mu. It again got lambda. Wherein sigma square equal to lambda by sigma square. It again got lambda. So since we have been saying that it depends on a fixed interval, so we can take the example of number of calls received by a call center in a node. So you can see here we have hour. Hour is a fixed interval of time, and the number of calls received by a call center in an hour. It is a fixed interval of time, events occurring at a constant rate. So these are a Poisson distribution and continuous, and again mean, which is an average, and variance depending upon mean. So binomial distribution, success in a fixed number of independent trials, and Poisson distribution models the number of events occurring with a fixed interval of time or space. So thank you guys, thank you for listening. This is Sanjay Rahul Janga